All right, so to pick up where we left off, we built out our nice little program. So if we run this, see where we left off, we were able to get the current list to display. We built a little menu system to change an index if we knew exactly what index we wanted to do. One thing within this, when we print this individual list, no, there we go. So in our program here, we had a nice little current list come out. We have to tell it what index. Now, it's not necessarily intuitive for people using the program to know that the index starts with a 0, right? Most people would think it starts with a 1. So in order to modify that to make the program look a little bit better, what we can do is use a for loop. And it's kind of like what we did when we talked about for loops before, and we want to kind of go through it. So if that list is equal to 0, we'll leave that. And instead of printing the current list is, we have this list here, for I in my list, print I. So it prints out this individual list over here. What would be nice is if it told us what index each one of these was. So to do that, all we have to do is come back into where we are going through each one of them for my list. And instead, we're going to use range. And we're going to start with our 0 and go up to the length of my list. -1, right? That will get us the total length inside of here. So if I come in here, we're going to put this in a quote there. So it's going to calculate my list, subtract 1, stick it inside of there, and that's what we're going to go up to. So now instead of running this, if I just save this as is, we'll run it to make sure we're getting what we want. And notice we get 1, 0, 1, 2. Now it's going to go up to that, but we want to actually include that. So let's take that off and make sure we get the numbers we're looking for. Run, run, and run. And now we get what we're actually looking for. So 0 is going to be cat, 1 is bat, 2 is rat, and 3 is elephant. Now to actually get it to print what we want out there, we have to modify our print statement. So we're going to come in here and we have I, and I looks good. And so we would do something like I plus a period plus, and we're going to throw a space after that. And then we want it to actually give us whatever that variable is. So if we go back to my list and we pass in I, that's going to tell us the index we want, which is going to actually give us the variable we're looking for. So if we hit run, now we look at it. Okay. So we have int and a stir, doesn't work. So because we're starting to concatenate, we would have to convert this I over to a string in order to get it back. This starts to get a little complicated when we're starting to do concatenations and different things like that. We'll talk more about a print statement. What is much easier, and we're going to go a little bit advanced here to make this easier overall, or better yet, I'll just show you what it looks like if you had to fix that. You would go str on your I, and now it would actually do what you want. There you go. So now if we look at our list, we have 0 is cat, 1 is bat, 2 is rat, and 3 is elephant. So if we want to do something like 1 and change our index, what index would you like to change? We know which one we're actually looking for. So if we say 0, we can say dog, and when it reprints the list, 0 is now dog. If we want to delete one, we can come in here and say which index we want to do. So we delete 0, and now there's a new 0 starting at bat. Okay. If we want to check to see if something is particularly in this, what we can do is use another function. So we're just going to create a new one here. Def check list. And we need to figure out what's in there. And to do that, we can use these in and not in operators. So if we say is blank in, and then whatever the list is, we will get back true or false inside of there. So we can do that with a real quick check if we want to. On this checklist, we can say global spam. And we could say while true. We're going to go back to doing something very similar to what we had here. So I'm just going to copy and paste that in, and we'll modify it. And we'll say what would you like to check to see if it, or put it this way. Let's do, please type what you would like to see if, it's a good verbiage here. Obviously, you would end up with some better verbiage there or grammar than what I'm typing in, but that's fine. So we're going to get an input here. And in this case, we call it index. We're just going to call it sample. And then we're going to say if sample. Now, this one, the only caveat to saying type none, if none, right? If we want to get back out of it, we don't want to do that because none could actually exist as a word inside of our list. So it would be better to say press enter to return to menu. Something like that. So over here, what we could do is just do a real quick check like this. And then if they just press enter, it's going to say nothing there. Then we can say returning to menu. Okay, break out of our while loop, and then into that mini function will go on. Otherwise, what we want to do then is say if sample in spam, right? That's going to see if it's in the list. And in this case, it is. Then we're going to say print and whatever they typed in, sample plus is in the list. Something very simple. Then we'll go ahead and break out of this while loop. We're not going to worry about an index error. And we're not going to worry about a try and accept because we're not really doing anything that needs to be try and accept. We're not converting numbers or doing anything like that. So we're going to go ahead and get rid of that content. The only thing we will do is on an else print sample is not in the list. And we can do a break. So even with this input here, we don't necessarily need a while true because we're not going to be able to sanitize their input other than making sure that they type something in. So if it's else, we're just going to go ahead and check it and make sure it works. Down here, we add another option, print 3, check if item is in list. And that sounds a whole lot better. Enter item. You want to see if it's in the list. Down here, we need to have a new one that points to our option. So if choice equals 3, then we're going to run our new function called checklist. All right, let's see if it works. So we got a new one over here. We can hit 3, enter in the item we would want to check to see if it's in there. We type dog, and it comes back with dog is not in the list and circles us back to the main menu. So it would be wise if we go ahead and give ourselves an extra space after we're done there. I'm going to throw a /n in here at the end of these. And now when we do a 3, we say dog, says dog's not in the list and returns us back to the menu. Now, another thing to deal with lists, and you want to pay attention to this multiple assignment trick, is the ability to assign different values that are in a list. So say we have a cat as a variable, and then we have a list with all these different adjectives. So we have fat, gray, and loud. Now, those are basically his size, his color, and his disposition. And we can assign those based on what you see here. So we can say size is going to be equal to the 0 index of this cat list. Color is going to be equal to the first or the 1 index, and disposition is equal to the 2 index. Instead of having to type 4 lines of code here, right? We got the original variable, the list, and then the 3 that we want to assign. we can do what's called a multiple assignment trick, where we just type those names in the order that we want them to be in and say that's equal to cat, which refers back to this list. Now, anytime we use the word size, we're going to get back what was this variable. Color would be the gray and disposition would be loud. So it saves you several lines of code. This is if there's only 3 items in the list. If there was 10, then you would have to create 10 new variables, each on their own line, to get those information out. This multiple assignment, we could just list all 10 of those in one single line. But I will tell you, this multiple assignment trick is on a quiz, it's on an exam, but you want to pay attention to how it works. Another option you have is called enumerate. So what that will do is allow you to cycle through and enumerate through the different items. So for example, if we have our list here spam, I'm just going to create a new file so that we can test this and not mess with our main program. Enumerate is handy because we've been doing like range of some list technique in order to get what we were doing before. We can actually come in and say for index item, which is going to give us back the number, and it's going to give us back the item in enumerate. And then we pass in whatever list that we want to enumerate. In this case, it's going to be spam. Now what we can do is say print, and we can have index with a space plus string str of, oops, I used 2 different ones here, sorry. Str of index plus whatever's in there, and we can say what the actual item is. So we could say, now I'll just go back here. Let's go back to our list. So instead of doing this checkup here, where we were looping through and actually giving the numbers up here in our print list, we use this range command. Instead of doing I and then coming back and actually calculating which I we want to pull out of there, what we can do is say index, comma, item. And instead of doing the range command, we're going to say enumerate spam. In this case, it's not going to be spam, it's my list because we're passing it into here. And now this structure works like we would have expected it to. So instead of I, we do index. And over here on my list, we can actually type in item. Now, if we save it, we're going to get that same output that we had before, but it's a little bit cleaner. We don't have to calculate the range in order to get the right index numbers, then calculate that list and plug it in there. What it's going to do is enumerate and pull out the first index that's in there. We're going to assign that to the keyword index. You put that in, it takes the value that was in that index, assigns it to item, and then you can do something with it here. So it's just a little bit cleaner way of doing, instead of having the range and then calling back to the function to figure out what the range item was. Okay. Other things you can do with lists is you can use random choice and random shuffle. So what that's going to do is take our list, and I'm going to show this over here in this one. So at first we need to import random. And if we wanted to pick a random option out of our spam line up here, we could say random dot random, or in this case, random dot choice, right? And in choice, we would pass in our list like spam. And in this case, I'm just going to print this out. Now I'm going to copy this 5 times. And then we're going to go ahead and run this just to see what happens. So when this random choice went through, is it randomly selected one of these options out of here and printed it out. The first 2 times it did it, it found rat. The second 2 times it found bat. And the last time it found elephant. So it's just a random choice instead of you having to calculate a random integer, right? So the other way of doing this, based on what you guys learned last week, you could do choice equals random dot rand int. Remember how we did that before? We needed to pass in the 2 numbers that we wanted to choose. So we would say something like 0 to the len of our spam in order to calculate that, and we would get back a choice. I could say print choice. And then once you get this whole thing, you're just going to get back a index. So then you would have to pass in something like spam and then do this whole thing inside of here as to what index you want to do. So now if we run this, you'll see that the first time it selected cat. Let's go ahead and throw in an extra print in here so we have a space to see that. So the first time now it selected elephant. What we did was just randomly create a number between 0 and the length of spam. So we got a random number to get the index out of it, plugged it in here, got an index, got a choice. It's easier to use this random dot choice. It's a much simpler line. It just says, go grab me something out of this list and just randomly selects a number. So a lot cleaner to use random choice. The other option you have is random shuffle. What random shuffle will do is reorder those items in the list. So if we say down here, we're going to say print spam, right? That's going to give us our list. Then we're going to do a random dot shuffle spam, and then we're going to print spam again. List in and out. Yeah, we don't need to do this anymore. All right, so we can see the first time that we printed out the list that we originally had, cat, bat, rat, elephant. When we did random shuffle, it shuffled them up and gave them in a different order. So you may do this if you are creating like a card shuffle game, or you're playing blackjack and you write blackjack game, something like that. That would make sense as to why you want to shuffle the cards. So in cards, instead of having this as spam, right, you could have ace, king, jack. Oh, that's not a jack. Queen, jack, and then you would obviously continue down your list of all the other cards that would be in there, right? So you would have 9, or actually a 10, right?
That's where you could like further index it by going down.
You could, right? So you could have it randomly select one of these, and then you could have another list over here that would come in and have a bunch of the suits, and you could print one before the other. Or you may have a list that says this is all the diamonds, right? And then you could do that. So you could have it randomly select. There's multiple ways that you can design it.
Yeah, I was just thinking like if you could put like the suits, like have the suits and then like index in that index.
Not yet. What you're talking about is more of a dictionary, which we'll cover here in about another week. Yep, I think that's next week actually. Yes, that you'll find out that that's much more beneficial to use a dictionary than it is a list. A list, the only thing it indexes by is number. But you could have this one here. So we're going to assume this is all the cards that we have, and we're going to call this diamond now. Let's go back to spam just to keep our other code collect. And then we can shuffle that in. So if we run, the first time it goes, it's ace, king, queen, but you'll notice when it shuffles, it puts them in different order. If we put the entire card list in there, we could shuffle that as well. So those two commands can be handy inside your midterm projects, depending on what you're building. We can augment assignment operators. So this is handy. With this one, say that we were going to loop through something, right? Like say we did, let's do it this way. We could say count equals 0 and say while count is greater than 0, or we can do it this way. Let's say 10. While count is greater than 0, print random dot choice from spam. And then what we can do is say count equals count minus 1, right? And what that's going to do is print out random selections out of those cards. And then it's going to subtract 1 from this count until count equals 0, and then it stops. Instead of doing count minus 1, so count equals count minus 1, we can actually augment that by just saying count minus equals 1. And what that will do is just a shorthand of the exact same thing. It will subtract 1 without us having to write out the longer version of it. You could do the same way if you wanted to add 1 and say, while count is less than 11, start at 0. It will do the same process. If you're trying to see what's going on, all we have to do is say print count, and this will help us troubleshoot. So we can say, or better yet, do this count. And then we would have to convert count over to a string in order to combine it here. So if we look at what our program's doing, we want to kind of debug it. Let's see, print count. Oh, I'm sorry, I hit equals here. It's supposed to be a plus. There we go. So we can see here, the first time count is 1, right? We start at 0, we plus equaled 1, and then we check to see what the new count is. The loop starts over until it gets all the way to 11, at which point it's 11, then the while is going to stop because now we're greater than 11. So the key here is that you can augment. Instead of saying spam equals spam plus 1, you can just simply say spam plus equals 1. Anybody have any questions so far? Okay, so lists have what are called methods, and methods they're similar to a function, except it's called on a value. So for example, in this example over here, we have spam, and there's different methods we can call on spam. So if I hit the dot, then we can do whatever methods, and you can see all these different methods, and we're about to cover those here in a second. So say we want to find a value in a list and get back the index of whatever that is. So we say spam dot index, and we want to find out what index is A in. Let's go ahead and print that so that we can see it on our screen. Go ahead and drop off this stuff. So again, what we want to do is find out which index A is currently in. So we run this because as a user, we don't know what's in spam, right? We didn't print it to the screen. So if we want to find out what index, we use dot index in here. Other methods that we can use is append. So say we want to add something to our list. At this point, we had no way of adding anything to our list. So if we want to add the next card into our list, we would use append. And we could put in 8. Now, we could say something even better and come up here and say print, what would you like to add to the list? We say add equals input. And then we want to append that to the list. So we would say spam dot append. We're going to put add in whatever they typed in for that string, and they're going to put it in here. Then we can print out our list again. So this little simple program is going to say, what would you like to add to the list? We're going to say 8. Oops, I hit the button twice. Sorry about that. Let's try that again. So what do we want to add? We want to add 8. I hit enter, and we can see it appended it to the end of the list. So this is something that we could go back and modify our original program that we created over here. And we could have a new option that says def add to list. And we would take this code that we have here. Let's go ahead and take a little bit of what we already had. There we go. And we could say, what would you like to add to the list? Enter item to add. We still want to check to see if they type in nothing. So we're going to use that same thing here. Check to make sure it's nothing. We'll return them back to the menu. Otherwise, we would run our spam.append and whatever they typed in, which we called sample, and return them back. At that point, we would go ahead and break and get us out of this loop. Then we need to come down here and add that option. So print 4. add item to list. Down here and create our choice down here. LF choice equals 4. Add to list. And now we can run our old program. All right, so we're in our old program over here, and we can now use this option of 4, add to the list, and we want to add a dog. Now, if we do it, we would want to reprint that list at the top. So what would be nice is when we first come back to our main program, instead of printing this list here, let's add that in our while true so we can actually see anytime we come back to the main menu. So 4, we're going to add dog. We come back and notice how dog got added into that new part of the list. We could then check to see if anything's in there. 3, check to see if dog is in. It says dog is in the list, and we could actually come back and tell it what index if we wanted to, right? We learned .index. So let's go back to that function. Check list. Okay, we say it's in the list and say print sample is in index. And then we got to get what index that was. So that would be spam.index. We pass in sample to see what index it comes back as. That's going to come back as a number. So we're going to need to string it and end our sample. Let's see what that happens now. What I do, I fat fingered something. Sample plus. Okay, so now we're going to check to see if it's in the list. We check dog. We say it's not in the list, right? We need to add it. So 4, add dog. Dog is now in the list. We can say 3, check it, dog. It says dog is in the list and it is in index 4. Lets us know that. Because we put this slash in here, we would actually rather put that after this one. So we'll just do a print. Notice how it separated this. That doesn't look very good. 4, dog, 3, dog. Now it tells us that it's in there in the list and it's in index 4. We can also insert. So append just tacks it on to the end of the list. We would also want to use insert. Say we want to specifically put dog in between rat and elephant. So to do that, we print our spam here. We could say print, where do you want to put an item? Item equals input. Or let's do it this way. What item would you like to add? We're going to just copy this. Add equals input. Okay, let's check. Sorry, getting caught up here. Okay, so we got the item that we want to add to the list, but now we're going to prompt and ask them, where would you like to add it in the list? Which is not item, but let's go ahead and call this item. We're going to call this place to get an index number in here. Now we're going to need to check to make sure that's a valid index that we actually want to put it in. So to make sure that that's a valid number, we would say if int place, right? That's what they typed in range of 0 to the len of spam. Then we would go ahead and pop that in on the index. So spam dot insert. And now insert takes 2 different things that they want to do. They want to know what index it's in there. So that is going to be our int of place. And then we need to put whatever we want to put in there. So that's our item that we gathered from the end user. Now we could try this and it should run. So it says, what would you like to add to the list? We're going to add dog. Where would we like to put it? We know that we want it to go at index 3 because we want it between rat and bat. So we're going to put a 3 in, and it does it. It would have been nice if we printed it after that. So let's print spam. Run. What would you like to add? Dog, index 3. And we can see the dog actually got added into our cards because that's what we had up here. So it got injected inside of there. Now, does anybody know what we need to do to kind of clean this up a little bit? Right? Because if I come in here, it's not really sanitized. If I say dog, where do you want to put the item? ASDF, the thing crashes because we're trying to convert that to an integer. So what should I do to help prevent somebody typing in random stuff here? While loop would be good. What else would we want? What are we going to do with this while loop? Anytime you try to convert a string to an integer and it's going to crash because they typed in something that wasn't able to convert to an integer, we should use a what? There you go. Try and accept. It's a test, right? We want to do our test. We use try and accept. So try to do this. Whoops. And if it works, great. If not, we'll accept and say print. That is not a valid index. And then it would re-loop them back over. If this worked, we would go ahead and put a break. So we can run. What would you like to add to the list? Dog, what item, where would you like to put it? We could put 10 and we get back, where do you want this number? So 10, in this case, it would actually try to do it, but it's going to break because when it tries to insert it in this place, that part's going to fail. So we would want to do an exception here on value error that says that that's not a valid index. Or actually, that's not a, this is index error, right? And this, we could copy again and just do a straight catch-all and say that's not a valid index as well. That's fine. So let's run it. What would you like to add to the list? That's not valid. That's not a valid index. That is not a number. There we go. So we hit run. What would you like to add to the list? A dog. We want to put it on index 10, and it just kicks us back out. So why would that kick us back out? We should be getting one of these errors in here, right? So the easiest way to test this would be to do what? Comment this out. Let's dedent this and remove this try so that we actually get our error. Let's see if that number is actually within that range, right? We need an else here that says print that is not a valid index. And the reason that is there is because we already did the check to see if it was in range. So instead of doing this to see if it was in the range, we could just simply do this. So try, let's go back and add in here. I'll explain why it was not working. Uncomment it out. We're going to just try to go ahead and insert it. If we try to do it and it doesn't work, now we're going to get our invalid index like we were expecting down here. So uncomment, we can just take this out. Let's run it again. There we go. Now it threw 10 in, and it tried to break it in there. 1, 2, 3, 4, 5. It should not have gotten a 10 in the dog. It just appended it at the end. But 10 is not a valid place in there. So this test isn't going to work very well because it's just going to shove it in. What we need to do is come back to what we had with this else and say that is not a valid index. Let's go ahead and take this index error. That's never going to happen. This except will if it's not an actual number. Let's go and put our try back. And make this work, we have to tab this whole thing in. Okay, so we're going to try dog again. We're going to put it in the 10 index, and now it's going to say that's not a valid index because we're going to try to see if that's in the range. If it's not, then it hits the else, prints an invalid index, and starts it back over. So we can say, where do we want to put it? In this case, we'll try 3. Now it actually injected it into that right index. Everybody see the difference between append and insert? Append is just going to shove it at the end. Insert is going to put it in a very specific spot. If we want to remove something, remember that we used delete before, right? But we have to know what index that was in there. Well, that's not always easy because we'd have to print out the list, tell them what index, they'd have to figure that out. We can use .remove and just pass the variable that we want to remove out of there, which is a whole lot easier in some cases. So the difference is when would I use delete versus when I would use remove. So delete is if you know what index you want to remove, right? You would have to know the index. You would use .remove if you know the value that you want to remove. So if we would do a search and we want to know if dog's in there, we would remove any dog that's in there. We can sort the list. So if we want to sort a list, all we have to do is say, let's come back here to our list number 2. We could say print spam.sort. We could just say spam. And before we do this, we could say sort spam.sort. Remember, we're dealing with methods. What this is going to do is organize this list in alphabetical order, and then it's going to put numbers after that. Thank you. Good job. Okay, so we're going to rerun our list here. We're going to say we're going to add dog, put it at 3, and notice that dog ended up back here at the end because we ended up sorting this alphabetically and numerically. So what it does is it at first puts these numbers first because these are strings, right? Then it goes with uppercase letters, and then it goes with lowercase letters after that. And that is how sort works. So then numbers, uppercase, lowercase. If we want to do the reverse of that, then we can say inside this method, reverse equals true. And now if we add dog 3, notice that it does the reverse now. So now it's lowercase, then uppercase, then numbers. It would not work if we actually set these to be true integers, like 10 and 9. If we try to run this now, we want to add dog, put it in 3. We're going to get an error because it cannot sort strings and integers in a list. They all have to be of the same type. So they all have to be integers or they all have to be strings, but you can't have a mix in between. Same way with float. You obviously can't put floats in there as well. Or if you had lists in lists, it wouldn't work there as well. All right. You can also quickly just reverse everything by saying dot reverse. So right now we have dot sort. Dot sort with reverse equal to true. They added a new method that is just straight reverse. And that will do the same thing, but it's a lot easier to remember. So in a list, we say dog, put it in 3, but it goes ahead and reverses it. Now notice in reverse, it's able to calculate those numbers as well as the strings. So there's a benefit of being able to use the dot reverse over dot sort with reverse equal true. This new method that we're dealing with here is a little bit smarter. All right. Anybody have any questions over lists and how they work? Lists are probably the most commonly used data type that's in this particular setup. Okay, couple more things that I want to work with. We have what are called immutable data types and mutable data types. What does that mean? So a list has a mutable data type, meaning that values can be added, removed, or changed inside a list. However, a string is immutable. In other words, we can't change a string. It is what it is. Once we've set it, we can override it with the new assignment, right? So if I say something like variable 1 equals dog, and then I say variable 1 equals cat, I'm not changing variable 1. I'm overriding what variable 1 is. There's no way for me to like take the O out of this string. I can't remove an O out of there. So strings are considered immutable. Lists are considered mutable because we can adjust. We can add, we can append, we can remove, we can change, do whatever we want. If I override the entire list, so if I go back to this list and I now say spam is equal to dog, cat, truck, something like that. Again, I'm not updating this list. I'm not removing all of these and adding these in here. It's just completely overriding that list. All right. Another immutable type is called a tuple. So a tuple is a lot like a list, only instead of using square brackets, like we do here with the list, we would use parentheses. The reason that you would use a tuple is you cannot modify it. So in a program, this would be like where you store some basic settings that nobody would ever change. Because at that point, I cannot modify spam. I don't have a dot append or a dot insert or anything like that. It's always going to be in those particular indexes, which is nice because I can't sort it. I can't mess up my settings and expect my font size to always be in the first one in the left, or the second index is going to always be something. So that is when you would want to use tuples. So lists are considered mutable. Tuples are immutable. Strings are immutable. Anybody have any questions about that? If you don't know which one you have, say you're inside your project and you want to figure out what is spam, you can use type and then pass in spam, and it will tell you what type it is. So if I run this, may not print it out to the screen here, but we'll try. Let's do dog. We want to put it in 3. It's not going to spit it out, but if I print this so I can see it on the end screen. It says class tuple. So we know at this point, spam is a tuple. If I come up here and do it before I convert spam or, reassign it, if I do dog 3, at first it's a list, then we overwrote the variable and created it into a tuple. So the type command can help us figure out what we're dealing with. Same way, it'll come back and tell you whether it's a string, if it's a float, whatever it is, you can use the word type in order to get it back. If I want to convert this tuple back to a list so I can start modifying it, then I would say list and then pass in that variable. At that point, it's going to convert it back to a list so I can use it. So dog 3, it starts off as a list. We converted it over to a tuple here, but then we converted it back to a list here so that we can modify and edit it. And you can do the same thing with tuple. You can convert a list. Once you get information from a user and you want to set it to so that it can't be modified anymore, you would convert it to a tuple. At that point, it's fixed. You can use the ID function here. That's just going to tell you what ID Python assigned a particular variable. Unique identity. Not too often do we actually use this particular ID function, but you may need to use it. Let's see, references, that's good. So here's some other modules. If we want to copy a list over to another section, we can use a new variable. So say I have this here of list, and say I want to make a copy of spam from up above, but call it something else. So I'm going to say new spam equals copy.copy, and I want to make a copy of spam and put it over here. So I don't want to overwrite spam and call it this. If I actually called this new spam equals spam, if I modify new spam, it's going to modify spam. Just makes a copy of it, but you are actually changing it. So for example, if I say new spam 0 is now equal to dog, and then say print spam, print new spam. We're going to mute out all of this up here because we don't want to do that anymore. You'll notice that they're an identical match of one another inside of here, right? So before we do this, to see the difference, let's go print spam, run. The first time spam is equal to this one, which is what we originally started with. At that point, we set new spam's 0 index to dog, but notice both spam and new spam are changed to dog. So if we want to make a copy so that we're not going to edit our original list, we would say new spam is equal to copy.copy spam, which will make a copy of it. Then we can modify it. Then we can print the difference. To use copy, we have to import copy up here at the top. Go ahead and run. And now notice that when we go ahead and print spam again, it remained as an ace king, where the new list was modified in the beginning. If we have lists within lists, so instead of saying 10, say we had a list of numbers in here. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Remember, lists can live within lists. So instead of us actually having them inside the outer list, we would check this. If we run this, you'll see what it looks like. See how we have this list inside of our original list? When we try to copy this, it will come down here. It does go ahead and put it in there. But when you start to try to modify things, it doesn't work very well. You would want to use deep copy, and that will make copies of the internal list and making sure that they stay permanently. So in this case, because we have lists within lists, we would want to use deep copy in order to save that. Now, if we modified this, it wouldn't conflict with what was up here before. All right, that pretty much wraps up everything inside of here. So this first one here, you want to look at this, right? This is a good practice project. And again, I encourage you to use these practice projects if you don't quite understand what's going on. So this project is, we have this list value, right? We want it to print or write a function, so def function, that takes the list value as an argument and returns a string with all the items separated by a comma and a space, with and inserted before the last item. So for example, if we pass this in with spam, we should get this out of it: apples, comma, bananas, comma, tofu, comma, and cats. Because this would be pretty easy if we did it the other way. If we said def print line, we're going to pass in spam or something, whatever you want to call it in. We're going to say spam in our case. And we're going to say print Now, if you guys remember the print value, we could take whatever's that line item in there, right? So we could say for item in spam, print item, sep, remember that's our separator, equals, comma, and we can do that. So let's save and run this, run. Of course, we have to actually call it, right? Functions are there, but they don't actually run unless we call it. So print line, and we need to say spam. Okay, so it printed this out. The separator was supposed to be a comma, but it printed it on each line. So to do that, we're actually going to come up here. And instead of printing item, we're going to print spam. See what that does. Okay, so that printed out the entire list. That's not really what we're after. How would we write this? Anybody have any ideas? We're just supposed to print one individual line. Should actually return a string. It shouldn't actually print. So if we come back to our list, we don't want to print. We just want to return whatever our new string is. So up here, we need to add something to a string, right? Does everybody remember strings? So what we can do is say base string, or new string in this case is what we called it, equals nothing, right? It's just an empty string at this point. We need to append to that string. Well, we can treat strings a lot like lists. So we could say new string dot append. And what are we going to append? Say the item. Let's return that. And then here we're going to say print line. Let's just say print new line spam. And up here, we're going to call this new line because it doesn't actually print. All right. So if we look here, it doesn't have, well, if I could spell new string correct, let's do that there. All right. So a string doesn't have the option of appending to it. So we're going to have to come up with a different way of appending. What would we do there? Anybody have any ideas? Again, our end goal is to result in something that looks like this. New string equals apples, comma, bananas, tofu, and cats. That should be our end result. It's not simple, right? So we kind of got to think through it and see where we're going to get it. And these type of practice projects, it's the reason I encourage you to do it, is because when you get to your next assignment, this is the kind of stuff that you're going to see. This week there is none, but next week when you start playing with this, you got to figure out how you're going to do this. I'm trying to do it without giving it an answer here. So. How would you add something to a string? You guys know how to do that. There you go. So if we start off with new string equals nothing, Then when we roll through every item inside of a span, we could say new string plus equals new string plus whatever item it is, right? Then we could return the new string and we could print that out. So let's comment this out. Whoops. Just comment that out because that's what we're trying to get to do. And our little print should come back with something like that. Okay, we got apples. So what happened there? We don't want to return the new string inside of our for loop, right? It just appended it the first time and then returned out. So let's try this again. Okay, so now we have apples, bananas, tofu, and cats all in one long string. So how could we tweak this plus that you were talking about so that we could get something that looks like this? Yep. So plus, comma, space, right? So if we run this, we're getting closer. Now we've got apples, bananas, tofus, and cats. But when we get to that last one, we don't want a comma at the end, and we need to insert and in there. So what's a good way of finding out once we hit that last index? We need to get a number, right? So that we can find out if we're at the last index. So instead of doing 4 item in span, we should probably do 4 item in what? What's that? Not yet. How do we get a number back? Do you remember how we did this earlier today? Use the range command, right? So we do the length of span. What this will do is give us back I. So let's use I. So for I in range of 0 to the total length of span, we're going to say new string equals new string. Instead of item, that's not going to do us any good anymore. We need, because item, or in this case, I, is a number. So we need to add spam and get that index of that. Now, if we run this, we just did a simple change. We get the same output. But the benefit is we now have this number I to figure out where we are in this list. So how do we check to see if we're at the last index? In Python, what do we use for checks? Not quite try. You could, but in this case, not a try, but a if, right? So if, and let's find out if we're at that last index, if I is equal to what? There you go. Len spam, right? We want the total length of span minus 1. That tells us when we got to the last one. There's many ways to do this, but that's the easiest way to do that, at least with what you guys know right now. So if I ends up being equal to this, then we say new string equals new string plus spam I, right? That puts that variable in. But what we actually want before that is our and. And then we're going to put this at the very end, right? So we don't want a comma before this one. We want it to say and then whatever that variable name is. So we go in here like this. If it's not the last one, then we'll use an else. And we'll do our normal one that we've been doing this whole time. Does everybody see?